How dangerous is the closest black hole to Earth? When we look up at the night sky, everything appears calm. Stars shine quietly above us. Planets follow their predictable paths around the sun. Distant galaxies glow faintly billions of light years away. The universe seems peaceful, but behind this tranquil view lies a cosmos filled with unimaginable forces powerful enough to destroy planets, tear apart stars, and reshape entire solar systems. Among the most mysterious objects in the universe are black holes. They emit no light. They reflect no light. In fact, they are completely invisible, and yet, they are among the most powerful structures ever discovered by science. Most people think of black holes as distant cosmic monsters that exist only in science fiction. But the truth is far more surprising. One of them exists relatively close to Earth, and that raises an important question. Just how dangerous is the closest black hole to our planet? Could it ever threaten the solar system? Could it somehow move closer? Could a black hole swallow Earth, or even the Sun? And should humanity be worried about any of this? To answer these questions, we need to take a journey deep into our galaxy. Today, the closest known black hole to Earth is called 0620-00. It lies roughly 3,300 light-years away. That may sound like a simple number, but the distance is almost impossible to comprehend. Even light, the fastest thing in the universe, needs more than 3,000 years to travel from Earth to this object. At first glance, that seems comfortably far away, and it is. But black holes are fascinating, not because of where they are, but because of what they can do. 062000 is not alone in space. It belongs to a binary system, paired with a small orange star that orbits it every few hours. The black hole itself remains invisible. However, its enormous gravity slowly steals material from its companion star. That stolen gas spirals inward, forming a glowing disk that reaches temperatures of millions of degrees. This brilliant disk was the first clue that revealed the black hole's existence. Without it, astronomers might never have found it at all. If we could somehow travel there, the sight would be extraordinary. An enormous dark sphere would hang against the stars, surrounded by a blazing ring of superheated matter, moving at incredible speeds. The very fabric of space would appear distorted. Light would bend. Background stars would warp into strange shapes. Reality itself would seem different. Yet despite its frightening appearance, a black hole is not a giant cosmic vacuum cleaner. This is one of the biggest misconceptions about black holes. Many people imagine them constantly sucking in everything nearby, but that's not how gravity works. If our sun were magically replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does today. The oceans would not be swallowed. The planets would not spiral inward. From a gravitational perspective, the black hole would pull on Earth just as strongly as the sun does now. The real problem would be the loss of sunlight, not the gravity. This simple fact explains why the nearest black hole poses no danger to Earth. It is simply too far away. However, black holes become deadly when something gets too close. As an object approaches a black hole, the difference in gravity between its near side and far side grows dramatically. These tidal forces can become so extreme that they literally tear matter apart. Imagine a planet slowly falling toward a black hole. At first, powerful earthquakes would shake its surface. Its atmosphere would begin escaping into space. The planet would stretch and deform under increasing gravitational stress. Then comes one of the strangest phenomena in the universe. Astronomers call it spaghettification. The black hole's gravity stretches the object into a long, thin stream of matter. Mountains, oceans, continents, and eventually the entire planet are pulled apart atom by atom. What was once a world becomes nothing more than a glowing ribbon of debris falling into darkness. The same fate can befall stars. When a star ventures too close to a black hole, gravity can rip it apart completely. The resulting explosion releases enormous amounts of energy and can briefly outshine entire galaxies. Events like these are often how astronomers discover black holes hidden across the universe. But there is another possibility that is even more unsettling. What if some black holes are wandering through the galaxy completely alone? These so-called rogue black holes drift silently through interstellar space. They have no companion stars, no glowing disks, and no visible signs of their existence. They are effectively invisible. Astronomers believe the Milky Way may contain millions of such objects. Most will never come anywhere near Earth, but theoretically, one could pass through our region of the galaxy someday. The chances are extremely small. Still, the possibility is fascinating. A rogue black hole passing near the solar system would not instantly consume planets. Instead, its gravity would gradually begin disturbing everything around it. Comets would change course. Asteroids would be scattered. Objects in the distant Oort cloud could be thrown toward the inner solar system. Over long periods of time, planetary orbits might begin to shift. Earth itself could eventually feel the effects. Fortunately, for such disruptions to occur, the black hole would need to pass extraordinarily close. The probability of that happening during the entire history of human civilization is essentially zero. Even so, the idea of an invisible object silently traveling through the darkness reminds us how little we truly know about our cosmic neighborhood. When discussing black holes, it's impossible not to mention the giant that resides at the center of our galaxy, Sagittarius A. This supermassive black hole contains roughly 4 million times the mass of the Sun. It sits about 27,000 light-years away, hidden in the heart of the Milky Way. Compared to the nearest black hole, Sagittarius A is vastly larger, yet it poses even less danger to Earth because of its enormous distance. For billions of years, the solar system has peacefully orbited the galaxy, while this giant remained far away at its center. Black holes like Sagittarius A are important because they allow scientists to study the most extreme environments in existence. Near them, time slows down, space bends, light follows curved paths. The laws of physics are pushed to their limits. In many ways, black holes are natural laboratories where we can explore the deepest mysteries of the universe. And those mysteries are profound. What happens beyond the event horizon? What exists at the center of a black hole? Can information truly disappear forever? Do wormholes exist? Could black holes reveal a deeper theory of reality that unites gravity and quantum mechanics? These questions remain unanswered. Yet every year, new discoveries bring us closer to understanding them. Today, humanity has photographed the shadow of a black hole. We have detected collisions between black holes using gravitational waves. We have watched space itself ripple from events that occurred billions of years ago. What once seemed impossible is now becoming observable science. So, how dangerous is the closest black hole to Earth? The answer may be surprising. Almost not at all. It is far too distant to affect our planet. It cannot suddenly pull the solar system toward it. It cannot swallow Earth. It poses no realistic threat to humanity, but its importance was never about danger. Its importance lies in what it teaches us. Black holes remind us that the universe is far stranger than it appears. They reveal the hidden forces shaping galaxies. They challenge our understanding of space and time, and they remind us how many mysteries still wait to be discovered. Somewhere in the darkness of the Milky Way, unseen black holes continue their silent journeys through space, invisible, mysterious, and largely unknown. Perhaps one day they will help humanity unlock the deepest secrets of the cosmos. Because every time we look into the darkness, we learn something new about the universe, and every answer we find leads to even greater questions beyond. That is the nature of exploration, and that is why we continue looking toward the stars. But the story doesn't end there. Because the closer scientists look at black holes, the more they realize that these objects are not merely cosmic destroyers. They may also be the key to understanding the deepest secrets of reality itself. Tocy, we need to move beyond the question of danger and ask something even more fascinating. What would actually happen if a human being traveled to a black hole? Imagine a future centuries from now. Humanity has mastered interstellar travel. Vast spacecraft cross the distances between stars. The solar system is no longer our only home. And one day, an ambitious expedition sets a course for the nearest known black hole. At first, the journey seems uneventful. The stars shine normally, space looks exactly as it always has, but as the spacecraft approaches its destination, strange things begin to happen. The universe itself starts to change. Stars behind the black hole appear distorted. Some stretch into glowing arcs, others seem to appear in multiple places at once. Light bends around the invisible object like water flowing around a stone. This phenomenon is known as gravitational lensing. The black hole's gravity warps space so severely that even light can no longer travel in straight lines. To the crew, the view would be unlike anything ever seen before. The black hole itself would remain completely dark, yet its presence would be revealed by the distorted universe surrounding it. The closer they travel, the stranger reality becomes. And then they approach the most famous boundary in all of physics, the event horizon. This invisible surface marks the point beyond which escape becomes impossible. Cross it, and every possible path leads deeper into the black hole. No engine is powerful enough to reverse the journey. No signal can return. No information can escape. From the perspective of someone far away, something extraordinary would happen. As the spacecraft approaches the event horizon, time aboard the vessel begins to slow. The ship appears to move more and more slowly. Its radio transmissions arrive farther apart. Its clocks seem to tick at an ever-decreasing rate. Eventually, the spacecraft appears almost frozen in time. Its light becomes redder and fainter, then it slowly fades from view. To distant observers, it never quite crosses the event horizon. It simply lingers there forever. But for the astronauts inside the spacecraft, everything feels completely normal. Their watches continue ticking. Their hearts continue beating. Conversations continue exactly as before. They experience no sudden shock. No dramatic crossing. No visible barrier. They simply continue forward. The strange difference between what they experience and what outside observers see is one of the most astonishing consequences of Einstein's theory of relativity. Time itself is not universal. It can flow at different rates, depending on gravity near a black hole. This effect becomes extreme. Imagine the crew spends only a few hours near the event horizon before somehow escaping. When they return home, they may discover that decades have passed on Earth. Perhaps centuries. Everyone they knew is gone. Civilizations have risen and fallen. The future has arrived without them. In a very real sense, a black hole can act as a one-way time machine, into the past, but into the future. And this isn't science fiction, it's a prediction supported by modern physics. Yet an even greater mystery lies beyond the event horizon itself. What happens inside a black hole? The truth is surprisingly simple. Nobody knows. Modern physics reaches its limits. Here Einstein's theory describes gravity with extraordinary accuracy. Quantum mechanics successfully explains the microscopic world. But inside a black hole, these two pillars of science collide. The equations stop making sense. At the center of the black hole lies something called a singularity, a point where density becomes infinite, a place where space and time themselves appear to break down. Physicists believe this infinity is not physically real. Instead, it signals that our understanding of nature is incomplete. Some deeper theory remains undiscovered, a theory capable of uniting gravity and quantum mechanics into a single framework. Many scientists believe black holes may ultimately lead us toward that breakthrough, and if they do, they could transform our understanding of reality forever. Because black holes force us to confront questions that go far beyond astronomy. Can information truly disappear? What is the nature of time? Is space itself fundamental? Could other universes exist? Might black holes be connected to wormhole shortcuts through space and time? For now, these questions remain unanswered, yet every new observation brings us closer. In 2015, humanity detected gravitational waves for the first time. These tiny ripples in spacetime were created by two black holes colliding more than 1 billion years ago. The event released more energy in a fraction of a second than all The stars in the observable universe combine, produce at that moment, and yet no visible light was emitted, only space-time itself trembled. For the first time, humanity wasn't merely looking at the universe, we were listening to it, and what we heard confirmed predictions made by Einstein a century earlier. But perhaps the most astonishing discoveries still lie ahead. Because every time scientists build a more powerful telescope, they uncover something unexpected. Every time they look deeper into the cosmos, new mysteries emerge. The universe continually reminds us that we have only begun to understand it, and nowhere is that more apparent than in the study of black holes. These invisible objects are not simply cosmic hazards, they are gateways to some of the deepest questions ever asked. Questions about existence itself. Questions about reality. Questions about the ultimate fate of the universe. And perhaps, one day, black holes will provide answers we cannot yet imagine, because the greatest discoveries in science often begin where certainty ends, and few places in the universe are more uncertain than the darkness beyond an event horizon. But if black holes are not likely to destroy Earth, if the nearest one is harmless, and if rogue black holes rarely pass near planetary systems, then what is the greatest black hole-related event that could ever affect our galaxy? To answer that question, we need to look far into the future, far beyond the lifetime of human civilization, far beyond the lifetime of Earth, far beyond the lifetime of the Sun itself. We need to witness the future of the Milky Way. At this very moment, our galaxy is moving through space at incredible speed, and so is another giant galaxy, the Andromeda Galaxy, located roughly 2.5 million light-years away. Andromeda is the nearest large galaxy to our own. For billions of years, the two galaxies have been slowly approaching one another, drawn together by gravity, and one day, they will collide. First, this sounds catastrophic. Two galaxies crashing into each other should produce unimaginable destruction. But reality is more surprising. Galaxies are mostly empty space, even though each contains hundreds of billions of stars. The distances between those stars are enormous. When the collision finally begins, direct impacts between stars will be extremely rare. Instead, gravity will reshape everything. The elegant spiral arms of both galaxies will become distorted. Massive streams of stars will be flung into intergalactic space. Entire solar systems will find themselves on completely new trajectories. Over billions of years, the Milky Way and Andromeda will gradually merge into a single enormous galaxy. But the most dramatic event will happen at their centers, because each galaxy contains a supermassive black hole. Sagittarius lies at the heart of the Milky Way. Andromeda possesses its own giant black hole as well. As the galaxies merge, these two cosmic titans will begin an incredibly slow dance. For millions of years, they will orbit each other, each revolution releasing gravitational waves into the fabric of spacetime, slowly losing energy, slowly drawing closer until eventually, the inevitable happens. The two black holes collide. The merger will be one of the most powerful events in the universe. For a brief moment, more energy will be released than billions of stars produce. Together, spacetime itself will shake. Gravitational waves will surge across the newly formed galaxy. If intelligent civilizations still exist at that distant time, they may witness one of the greatest spectacles in cosmic history. Yet even this unimaginable collision is unlikely to threaten Earth directly, because by then, our planet will face a much more immediate problem, a problem much closer to home: the Sun. Throughout history, black holes have captured our imagination as cosmic monsters, invisible destroyers capable of consuming stars, objects that bend space and time, the ultimate forces of destruction. But for Earth, the greatest threat has never been a black hole. The greatest threat is the star that gives us life every day, our Sun. Right now, The sun appears stable, reliable, and changing. But stars do not live forever. Deep within its core, the sun continuously converts hydrogen into helium. This nuclear fusion releases the energy that warms our planet and powers every ecosystem on Earth. Yet the sun's fuel supply is finite, and one day, it will begin to run out. Our star is approximately 4.6 billion years old. It is already halfway through its life. In about 5 billion years, the sun will enter the final stages of its evolution. The core will contract. Temperatures will rise. The outer layers will expand enormously. The sun will transform into a red giant. Mercury will disappear first, then Venus, and eventually, Earth may share the same fate. Some scientific models suggest our planet will be swallowed entirely. Others indicate that Earth may survive, orbiting just beyond the swollen atmosphere of the dying sun. But either way, life will be gone long before then, hundreds of millions of years before the red giant phase begins. Increasing solar brightness will slowly transform Earth. The oceans will evaporate, temperatures will soar, the atmosphere will change beyond recognition. Complex life will become impossible. The planet will slowly become a barren world, and none of this requires a black hole.no, rogue object.no, galactic catastrophe.no, cosmic monster hidden in the darkness. Only the natural aging process of a star. Ironically, the nearest black hole will survive far longer than the sun itself. Long after our star has died, black holes will remain. They are among the longest-lived objects in existence. For many years, scientists believed black holes might last forever. Then a remarkable discovery changed everything. In the 1970s, physicist Stephen Hawking proposed that black holes are not completely black. According to quantum physics, they slowly lose energy over time. This phenomenon became known as Hawking radiation. The process is incredibly slow. A stellar black hole could survive for timescales so vast that they are difficult to comprehend. Not millions of years, not billions, not even trillions. Numbers so large that the current age of the universe seems insignificant by comparison. Yet, even black holes are not eternal. Given enough time, every black hole will gradually evaporate. One by one, the last remnants of collapsed stars will disappear. The universe will continue aging. Stars will stop forming. Galaxies will grow dark. The night sky will slowly fade. Eventually, the cosmos may enter a state physicists call the heat death of the universe, a future where almost all usable energy is gone. No shining stars. No glowing nebulae. No brilliant galaxies. Only darkness, cold, and vast empty distances. And in that unimaginably distant era, the final black holes will be among the last objects left, the last giants of a dying universe, silent, invisible, alone. Then, after incomprehensible stretches of time, even they will vanish, their final energy radiating away into the darkness, the last black hole evaporating in a flash too faint for anyone to witness, the final chapter of an aging cosmos. And that realization changes the way we think about black holes. They are not eternal monsters. They are temporary, just like stars, just like planets, just like galaxies. Even the most powerful objects in existence are only brief moments in the larger story of the universe. And perhaps that is the most fascinating lesson of all. The closest black hole to Earth is not important because it threatens us. It is important because it reminds us how much remains unknown. Every black hole represents a mystery, a doorway to unanswered questions, a challenge to everything we think we know about space, time, and reality itself. And somewhere out there, hidden among the stars, countless more black holes are waiting to be discovered. Silent travelers moving through the darkness, witnesses to billions of years of cosmic history. Perhaps one day humanity will reach them. Perhaps one day we will finally understand what lies beyond the event horizon. And perhaps, hidden within those answers, we will discover something even greater than black holes themselves. The true nature of the universe, and our place within it. But perhaps the most unsettling question of all still remains unanswered. What if the greatest black holes in the universe are not the ones we have already discovered? What if the most important black holes are still hidden? Right now, astronomers have identified thousands of black holes. Some contain only a few times the mass of our Sun, others hold millions or even billions of solar masses. Yet, these discoveries may represent only a tiny fraction of what actually exists. The reason is simple: black holes are notoriously difficult to find. Unlike stars, they do not shine. Unlike planets, they do not reflect light. They reveal themselves only through their influence on the surrounding universe. And that means countless black holes may be drifting through the darkness completely unnoticed. Imagine flying above the Milky Way. Below you stretches a vast spiral galaxy containing hundreds of billions of stars. Bright clusters illuminate the spiral arms. Nebulae glow in brilliant colors. New stars are being born in giant clouds of gas and dust. But between those islands of light lies something else: darkness. Immense regions where almost nothing can be seen. And hidden within that darkness may be millions upon millions of invisible black holes. Some estimates suggest that the Milky Way alone could contain more than 100 million stellar black holes. Most have never been detected. Most may never be detected. They wander silently through the galaxy like unseen ghosts, passing between stars, crossing enormous distances, leaving almost no trace behind. This realization changes our perspective completely. The black holes we know about may represent only the tip of a cosmic iceberg. The vast majority remain hidden, waiting to be discovered. But the mystery grows even deeper, because scientists have begun asking a remarkable question. What if some black holes are older than the stars themselves? What if certain black holes were born before galaxies existed, before planets, before stars, before the universe looked anything like it does today? To understand this possibility, we must travel back nearly 14 billion years, back to the earliest moments after the Big Bang. The newborn universe was unimaginably hot, unimaginably dense. Energy filled every corner of existence. Matter had barely begun to form. Space itself was expanding at extraordinary speed. Within this chaotic environment, tiny fluctuations in density existed everywhere. Most eventually smoothed out as the universe expanded. But some physicists believe a few regions may have become so dense that gravity overwhelmed everything else. Instead of forming stars, these regions collapsed directly into black holes. These hypothetical objects are known as primordial black holes. Unlike ordinary black holes, they would not be the remains of dead stars. They would be relics from the birth of the universe itself, ancient objects that have existed since the beginning of time. If primordial black holes exist, they could be almost any size. Some might contain the mass of a mountain, others could outweigh entire star systems, and they might still be scattered throughout the cosmos today. Invisible, silent, ancient beyond imagination. The idea becomes even more intriguing when we consider another great mystery: dark matter. For decades, astronomers have known that most of the matter in the universe cannot be seen. Galaxies rotate too quickly for the amount of visible material they contain. Galaxy clusters behave as though enormous amounts of hidden mass surround them. Something invisible is shaping the cosmos. Yet nobody knows exactly what it is. Numerous theories have been proposed: exotic particles, unknown forms of matter, entirely new branches of physics. And among those possibilities lies a fascinating idea: could primordial black holes account for at least part of dark matter? Could countless tiny black holes be filling the universe right now, silently influencing everything around them? At present, there is no definitive evidence. The mystery remains unsolved, but it highlights an important truth: the universe may be far stranger than we currently imagine. Every answer we uncover seems to reveal an even greater mystery waiting beyond it. And nowhere is this more obvious than in the study of black holes, because black holes force us to confront some of the deepest questions ever asked. What is reality? What is time? What is space? What existed before the universe began? Can information truly be destroyed? Is our universe unique? Or are there countless others beyond our reach? For centuries, humanity looked at the night sky and wondered what lay beyond the stars. Today, we possess powerful telescopes, spacecraft explore distant worlds, observatories detect ripples in spacetime itself, and yet some of the most fundamental questions remain unanswered. Black holes sit at the center of many of them, not because they are dangerous, not because they threaten Earth, but because they mark the boundary between what we know and what we do not. Every generation of scientists has pushed that boundary a little farther. Each discovery has revealed a larger and more complex universe. Once, we believed Earth was the center of everything. Then we learned we orbit the sun. Later, we discovered the sun is only one star among hundreds of billions. Then, we realized our galaxy is only one among trillions. Each breakthrough made humanity seem smaller, yet each one also expanded our understanding of existence. Black holes may represent the next great step in that journey. Perhaps one day we will understand what lies inside them. Perhaps we will uncover a theory capable of explaining both gravity and quantum mechanics. Perhaps we will learn whether wormholes truly exist, or whether black holes are connected to entirely new realms of reality. For now, however, they remain among the greatest mysteries in science, silent, invisible, and endlessly fascinating. And somewhere, deep in the darkness between the stars, the nearest black hole continues its lonely orbit, 3,300 light-years away, far too distant to threaten Earth, far too distant to affect our lives, yet close enough to remind us of something extraordinary. The universe is filled with wonders we have barely begun to understand, and every time humanity looks deeper into the darkness, we discover that the darkness was never empty at all. It was simply waiting for us to learn how to see it. But what if the mystery goes even deeper? What if black holes are not merely the end of something, but the beginning of something else? For decades, scientists viewed black holes as cosmic dead ends. A star collapses, gravity overwhelms every force trying to resist it. An event horizon forms, and everything that crosses that boundary is lost forever. Simple, final, absolute, at least. That was the traditional view, but modern physics has uncovered a troubling problem. According to quantum mechanics, information can never truly be destroyed. The exact state of every particle must always be preserved in some form, yet black holes appear to do exactly the opposite. They swallow matter. They swallow light. They swallow information. And if that information disappears forever, one of the most successful theories in science may be fundamentally wrong. This contradiction became known as the black hole information paradox, and it remains one of the greatest unsolved mysteries in physics. Imagine taking an encyclopedia containing every piece of human knowledge ever written, every language, every scientific discovery, every work of art, every story, then throwing it into a black hole. What happens to that information? Does it cease to exist? Does it somehow remain stored inside? Or is it encoded on the event horizon itself? Scientists still do not know. Some theories suggest that information is preserved in incredibly subtle quantum effects. Others propose that information may be transformed rather than destroyed, and some ideas are even stranger. According to one hypothesis, everything that falls into a black hole could leave a kind of imprint on its surface, like footprints frozen in spacetime. From a distance, the black hole appears smooth and featureless, but hidden within its quantum structure may be an unimaginably detailed record of everything it has ever consumed. If true, black holes may not erase information at all. They may be the universe's ultimate storage devices. But there is another possibility that is even more extraordinary. What if black holes are connected to other regions of spacetime? The idea first emerged from equations developed by Einstein and physicist Nathan Rosen. Together they described a theoretical structure now known as an Einstein-Rosen bridge. Most people know it by another name, a wormhole. In theory, a wormhole could connect two distant points in space, or perhaps even two different moments in time. Instead of traveling across millions of light years, a spacecraft might simply pass through a shortcut, one entrance, one exit, a tunnel through the fabric of reality itself. The mathematics allows such solutions, but there is a problem. Wormholes appear to be incredibly unstable. Most calculations suggest they would collapse almost instantly, long before anything could travel through them. Yet, physicists continue studying the possibility, because if stable wormholes can exist, they would completely transform our understanding of the universe. Entire galaxies could become accessible. Interstellar travel might become practical. Even the concept of distance itself could lose much of its meaning. And since black holes already warp spacetime more dramatically than any other known object, many researchers wonder whether the two phenomena might somehow be connected. At present, there is no evidence that real black holes contain traversable wormholes, but the question remains open, and in science, unanswered questions often become the source of future discoveries. The deeper we investigate black holes, the stranger the universe appears. Some theories suggest that every black hole could contain an entirely new region of spacetime. Others speculate that black holes may give birth to new universes. Imagine that for a moment, every black hole becoming the seed of a separate cosmos, a universe hidden beyond an event horizon, with its own stars, its own galaxies, perhaps even its own laws of physics. Some cosmologists have explored the possibility that our own universe might have originated in a similar way. Perhaps the Big Bang itself was connected to a black hole existing in another reality, a child universe born from a parent universe, a cosmic chain stretching endlessly across existence. At the moment, these ideas remain highly speculative. There is no observational evidence confirming them, but they illustrate just how profoundly black holes challenge our understanding of reality, because every path of investigation eventually leads to the same conclusion. We simply do not know enough, and perhaps that is what makes black holes so captivating. Not their power, not their danger, but their mystery. They represent the edge of knowledge itself, a boundary where our best theories begin to fail, a place where certainty gives way to possibility. Throughout history, humanity has always been drawn toward the unknown. Ancient sailors crossed oceans without knowing what lay beyond the horizon. Explorers ventured into uncharted continents. Astronomers turned telescopes toward distant worlds. And now, modern science is exploring frontiers even stranger than anything our ancestors could have imagined. Frontiers made not of land or sea, but of space, time, gravity, and the hidden structure of reality. Black holes stand at the center of that exploration, silent monuments to everything we have yet to understand, and perhaps, somewhere in the centuries ahead, a future generation will finally solve the mysteries that still puzzle us today. Perhaps they will discover what lies beyond the event horizon. Perhaps they will unlock the secrets of quantum gravity. Perhaps they will reveal whether our universe is unique or merely one among countless others. Until then, black holes remain among the most fascinating objects ever discovered, not because they threaten us, but because they challenge us. They remind us that even after centuries of scientific progress, the universe still holds secrets beyond our imagination. And maybe that's the most important lesson of all. The more we learn about the cosmos, the more we realize how much remains unknown, and somewhere beyond the light of distant stars, beyond the reach of our most powerful telescopes, beyond the limits of our current understanding. But even if humanity eventually answers all of these questions, a final mystery will remain: the mystery of our own future, because every discovery we've discussed, from black holes and gravitational waves to the birth and death of galaxies reveals something remarkable. The universe is not static. Nothing lasts forever. Stars are born. Stars die. Galaxies collide. Black holes grow. And over unimaginable spans of time, the cosmos itself continues to evolve. The night sky we see today is only a temporary snapshot of a much larger story that began nearly 14 billion years ago, and one that will continue long after humanity is gone. If we could somehow fast forward billions of years into the future, the universe would look very different. The familiar constellations would no longer exist. The stars that guide our night skies would have drifted apart. Entire stellar neighborhoods would be unrecognizable. The Milky Way and Andromeda would have merged into a single giant galaxy. New generations of stars would be born from clouds of gas created during their collision. Others would already be reaching the ends of their lives. The cosmos would continue changing slowly, relentlessly, and throughout this vast future, black holes would become increasingly important. Every massive star that dies leaves behind a compact remnant. Some become neutron stars, others become black holes. As billions of years pass, more and more black holes accumulate throughout the universe. They merge, they grow, they consume matter. Gradually, they become some of the dominant objects in existence. Imagine a future so distant that nearly every star has exhausted its fuel. The brilliant galaxies that illuminate today's universe begin to fade. Star formation slows, then eventually stops. The cosmic age of light starts drawing to a close. First, this future seems impossible to imagine. After all, stars appear eternal on human timescales. Civilizations rise and fall beneath their light. Entire species evolve, while stars barely change at all. But even stars have limits, and eventually, those limits are reached. The universe enters what some physicists call the degenerate era, a time when ordinary stars become increasingly rare. White dwarfs drift through darkness, neutron stars cool, black holes roam among the remnants of long-dead galaxies. The night sky becomes darker than anything we can currently imagine. For trillions of years, these remnants continue their silent journeys. Occasionally, two black holes encounter one another. Gravity pulls them together. They begin a slow orbital dance. Over time, gravitational waves carry away energy. The orbit shrinks, the rotation speeds up, and eventually, they collide. The merger releases an enormous burst of gravitational energy. Not visible light, not radiation, but ripples in spacetime itself. Then silence returns. One larger black hole remains, waiting for the next encounter, waiting for the next merger. As the ages pass, the universe becomes increasingly dominated by darkness. Yet, even darkness is not permanent. Because of Hawking radiation, every black hole is slowly losing energy. The process is unimaginably slow. A black hole with several times the mass of the Sun could survive for timescales so vast that writing them down requires numbers with dozens of digits. But eventually, even those giants begin to shrink. Very slowly, almost imperceptibly, year after year, trillion after trillion years. The black hole becomes light, smaller. Its evaporation accelerates. And finally, after durations beyond ordinary comprehension, the process reaches its end. The black hole disappears, not with a roar, not with an explosion capable of destroying galaxies, but with the final release of energy into an almost empty universe. One more giant gone forever, one more chapter closed, and eventually, the same fate awaits every black hole. The stellar black holes, the supermassive black holes, even the monsters that sit at the centers of galaxies, one by one, they vanish. The last lights disappear. The last structures fade. The last remnants of cosmic history dissolve into the darkness. Imagine standing at the end of time itself. No stars, no planets, no galaxies, no black holes. Only an expanding universe growing colder and emptier with every passing moment. would anything remain? Physicists still debate that question. Some believe the universe will continue expanding forever. Others suggest entirely different endings. Perhaps new physics awaits discovery. Perhaps the vacuum of space is not truly stable. Perhaps reality itself may eventually transform into something completely unexpected. The truth is that nobody knows. And that uncertainty is what makes the universe so extraordinary. Every generation believes it has learned most of what can be known. Then, a new discovery changes everything. A new mystery appears. A new frontier emerges. Black holes have done exactly that. Once considered mathematical curiosities, they are now central to our understanding of modern physics. They have revealed gravitational waves, helped test Einstein's theories, challenged our understanding of information, quantum mechanics, and spacetime itself. And they continue raising questions that may occupy scientists for centuries to come. So, when we ask whether the closest black hole is dangerous, we are really asking the wrong question. Its true value lies elsewhere. The nearest black hole is important because it reminds us how much remains unexplored, how many mysteries still exist beyond the reach of our current knowledge, and how every answer leads to new questions. Somewhere, right now, the black hole known as 062000 continues orbiting silently with its companion star, and seen by human eyes, unaware of the curiosity it inspires. 3,300 light-years away, it drifts through the Milky Way exactly as it has for millions of years, a dark object in a dark universe. Yet through science, humanity has managed to discover it, to study it. To understand at least part of its story, and perhaps that achievement says something important about us. We are a species living on a small planet orbiting an ordinary star, yet we have learned to measure the movements of galaxies, to detect ripples in spacetime. To study objects thousands of light-years away that emit no light at all. We have learned to see the invisible, and that journey is far from over, because somewhere beyond the next discovery, beyond the next telescope, beyond the next breakthrough, another mystery is waiting, another question without an answer, another piece of the universe waiting to be understood. And as long as those mysteries exist, humanity will continue looking upward, searching, exploring, wondering, because curiosity has always been our greatest engine of discovery, and perhaps, one day, it will lead us to answers even stranger than black holes themselves. Until then, the darkness remains, not as something to fear, but as an invitation to keep exploring the infinite universe that surrounds us. But perhaps the greatest mystery is not what black holes are. Perhaps the greatest mystery is why the universe allows them to exist at all. Think about it. Among all the stars, planets, nebulae, and galaxies scattered throughout the cosmos, black holes occupy a unique place. They are the only known objects where our current understanding of physics breaks down completely. Every equation eventually points toward the same conclusion. Something is missing. Some fundamental piece of reality remains hidden from us. And history suggests that whenever science encounters such a barrier, a revolution follows. Centuries ago, astronomers believed the heavens were perfect and unchanging. Then telescopes revealed mountains on the moon, storms on Jupiter, and countless stars beyond the reach of the naked eye. Later, Newton explained gravity. Then Einstein showed that gravity itself was not a force in the traditional sense, but a curvature of spacetime. Each breakthrough transformed our view of reality, and black holes may be preparing us for the next transformation. Somewhere within their mysteries may lie a deeper description of nature, a theory capable of explaining everything from subatomic particles to entire galaxies. A theory physicists have searched for generations, the so-called theory of everything. For decades, researchers have attempted to unite the two great pillars of modern science. On one side stands general relativity, Einstein's masterpiece, a theory describing gravity, planets, stars, and the large-scale structure of the universe. On the other side stands quantum mechanics, a theory governing atoms, particles, and the microscopic world. Individually, both theories work extraordinarily well. They are among the most successful scientific achievements in human history. But inside a black hole, they refuse to cooperate. The mathematics becomes contradictory, the predictions become impossible. It is as if nature is telling us that our picture of reality remains incomplete, and somewhere beyond that contradiction lies a deeper truth. Perhaps black holes are the doorway leading us toward it. Imagine future scientists finally solving the mystery. Imagine a civilization thousands of years from now, its technology far beyond anything we can currently imagine, its understanding of physics vastly more advanced. Perhaps they will look back on our era the same way we look back on ancient astronomers who believed Earth was the center of the universe. Perhaps concepts that seem impossible today will appear obvious to them. Maybe they will understand what happens inside black holes. Maybe they will travel safely near event horizons. Maybe they will harness phenomena that currently exist only in theoretical equations. Or perhaps the truth will be stranger than anything we have imagined. After all, nearly every major discovery in astronomy has revealed a universe more bizarre than expected. Nobody predicted neutron stars before they were discovered. Nobody imagined quasars would outshine entire galaxies. Nobody expected gravitational waves to be directly detected. Reality repeatedly proves itself more creative than human imagination, and black holes may represent the greatest surprise of all. Somewhere in the distant future, explorers may stand at the edge of an event horizon not with fear, but with curiosity, the same curiosity that once drove sailors across unknown oceans, the same curiosity that launched the first spacecraft beyond Earth, the same curiosity that continues pushing humanity toward the stars. Because exploration has never been about certainty. It has always been about stepping into the unknown, and few frontiers are more unknown than a black hole. Yet even as we dream about distant futures, it is worth remembering where we are today. At this moment, humanity exists on a small world, orbiting an ordinary star in the outer regions of an ordinary galaxy. Our entire history occupies only a tiny fraction of cosmic time. Every civilization ever built, every empire, every invention, every person who has ever lived, all have existed during a brief moment in the life of the universe. And yet, during that brief moment, we learned something extraordinary. We learned that the universe is understandable, not complete yet, but enough to reveal its wonders, enough to discover invisible black holes thousands of light years away, enough to detect collisions between objects we cannot even see, enough to glimpse the shadow of a supermassive black hole at the center of a distant galaxy. That achievement alone is remarkable. It reminds us that curiosity is one of humanity's most powerful abilities. It allows us to look into darkness and find meaning. To confront mysteries and gradually uncover answers. To transform the unknown into knowledge. And perhaps that is the true lesson of black holes. They are not symbols of destruction. They are symbols of discovery. They remind us that the universe still contains secrets beyond our imagination, and that no matter how much we learn, there will always be new horizons waiting beyond the ones we have already crossed. Somewhere tonight, far beyond the reach of our eyes, the nearest black hole continues its silent journey through the Milky Way. Invisible. Ancient. Mysterious. It does not threaten Earth. It does not seek us. It simply exists, a dark object drifting through an even darker cosmos. Yet because of it, scientists ask new questions, build new instruments, develop new theories, and push the boundaries of knowledge a little farther. Perhaps one day, those efforts will reveal answers that change everything. Perhaps they will uncover truths more profound than we can currently imagine. Until then, the black hole remains a silent guardian of unanswered questions, a reminder that the universe is far larger, stranger, and more beautiful than we often realize. And as long as those mysteries remain unsolved, humanity will continue its journey, looking outward, looking deeper, searching for understanding among the stars, because Every mystery solved opens the door to another, and somewhere beyond the darkness, beyond the edge of our current knowledge, the next great discovery is already waiting. And so, after everything we've explored, one conclusion stands above all others. The closest black hole to Earth is not something humanity needs to fear. It won't suddenly appear in our skies. It won't pull the solar system apart, and it won't swallow our planet. It more than 3,000 light-years away. It remains a distant and harmless neighbor in the vast expanse of our galaxy, yet its existence teaches us something extraordinary. It reminds us that the universe is far stranger than it appears, a place where invisible objects can bend light, slow time, and challenge the very foundations of physics, a place where stars can be torn apart, where galaxies collide, and where mysteries still wait beyond the limits of human understanding. Throughout this journey, we've traveled from the nearest black hole to the center of the Milky Way. We've explored rogue black holes drifting through interstellar space. We've witnessed the future collision of galaxies, the death of stars, and the unimaginable fate awaiting the universe itself. And through it all, one truth has remained constant. The more we learn about the cosmos, the more we realize how much remains unknown. Perhaps that is what makes astronomy so fascinating. Every answer reveals a new question, every discovery opens a new frontier, and every glimpse into the darkness brings us one step closer to understanding our place in the universe. Somewhere right now, the nearest black hole continues its silent journey through the galaxy, unseen, unheard, a reminder that the greatest mysteries are often hidden where we least expect them, and perhaps one day, future generations will uncover secrets that today seem impossible to imagine. Till then, humanity will continue looking toward the stars, searching, questioning, exploring, because curiosity has always been the force that drives us forward. And as long as mysteries remain, our journey will never truly end. Thank you for joining me on this incredible journey through one of the most fascinating mysteries in the universe. If you enjoyed this story and would like to see more documentaries about space, black holes, distant worlds, and the greatest mysteries of the cosmos, be sure to leave a like, subscribe to the channel, and turn on notifications so you never miss a future episode. Your support helps bring more of these stories to life and allows us to continue exploring the wonders of the universe together. And let me know in the comments, if humanity could visit any object in space, where would you go first? Thank you for watching. Stay curious, keep exploring, and never stop looking up at the stars. I'll see you in the next journey through the cosmos.